So its cell and its plasma membrane and inside the cell are located proteins that have negative charge, and they create the negative charge inside the cell. And as we know, some ions are considered intracellular and some extracellular. Extracellular ions are ions that have higher concentration outside the cell, and it's sodium, chloride, and calcium. So they have high extracellular concentration and low intracellular concentration. We have only one important intracellular ion, and it's potassium. So potassium concentration inside the cell is higher than potassium concentration outside the cell. And ions also have charges. Sodium, calcium, and potassium are positively charged ions, and chloride is negatively charged. And this distribution of positively and negatively charged ions creates positive charge on the outer surface of the cellular membrane and negative charge on the inner surface of the cellular membrane. And this difference in charges creates so-called membrane potential. And the key here is that when we are talking about the membrane potential, we mean only this charge on the inner surface of the cellular membrane, and the resting membrane potential is minus 70. So only this charge on the inner surface of the cellular membrane is important. This charge is formed by the sum of charges of ions and proteins inside the cell. So we can write this as minus 70 equal to intracellular potassium concentration plus sodium concentration plus calcium concentration plus chloride concentration plus concentration of proteins. So because the value of this membrane potential is negative, obviously in rest state, negatively charged proteins and chloride prevails over positively charged potassium, chloride, and calcium. And through this membrane, ions move into the cell and outside the cell. Because ions have charges, they cannot cross easily through the membrane. So to transport them, cells have channels. This movement through the channels occurs by so-called electrochemical gradient. We can divide this term in two. Chemical force means that ions move by concentration gradient, from high concentration to low concentration. For example, because sodium is extracellular ion, once sodium channels open, by concentration gradient sodium will go into the cell, and it's the dominant force. Additional force is electric. Electro means that ions move by charges. As we know, opposites attracts, so positively charged ions as sodium tends to move inside the cell because inside the cell is negative charge. So sodium is extracellular ion, thereby by chemical force sodium moves inside the cell, and because sodium has positive charge, by electric force sodium moves also inside the cell. For calcium is the same as for sodium, also extracellular ion and has positive charge. Chloride is extracellular ion, thereby by chemical force chloride moves inside the cell. And because chloride has negative charge, by electric force chloride moves outside the cell. In this case, when chemical force and electric force acts in opposite directions, the dominant force is chemical. So in this case, the force that push chloride will be equal to chemical force minus electric force. So because chloride concentration is high outside the cell, chloride moves inside the cell. But not so rapidly as sodium and calcium, for example, because in case of chloride, force is much smaller. And potassium is intracellular ion, so by chemical force potassium moves outside the cell, and by electric force potassium tends to move inside the cell. Because chemical force is the dominant force, potassium moves outside the cell. And all these ion movements occurs until each ion reaches equilibrium potential. Equilibrium potential is the moment when chemical force is equal to electric force, so they are in balance, and in this case chemical force minus electric force equals 0, so there will be no ion movement. For example, potassium by chemical gradient moves outside the cell and by electric force inside the cell. So in rest, when membrane potential equal to minus 70, potassium moves outside the cell, driven by the dominant chemical force. And chemical force is basically potassium concentration inside the cell minus potassium concentration outside the cell. And recall that membrane potential is formed by the sum of ions charges inside the cell. So minus 70 equals to intracellular potassium plus sodium plus calcium plus chloride plus proteins. For example, if potassium channels will remain open and potassium will move out of the cell, then with every potassium ion that will leave the cell, the amount of potassium ions inside the cell decrease. So potassium concentration gradient will decrease, so the chemical force will decrease. And because positively charged ions leave the cell, membrane potential decrease. Membrane potential become more negative, -80 for example. So because the inner wall of the plasma membrane becomes more negative, electric force that keeps potassium inside the cell will increase. And at some point, membrane potential will reach a certain value when chemical force that pushes potassium out of the cell will be equal to electric force that keeps potassium inside the cell. For potassium, this value is -95. And when a chemical force is equal to electric force, this moment called electrochemical equilibrium. And at this moment there will be no movement of potassium through the cellular membrane at all, because both forces that act in opposite directions are equal. And important that for each ion, the value of equilibrium potential is different. So what is depolarization? Depolarization is a state when membrane potential, basically at this negative value, that is formed by intracellular ions, becomes more positive. So this value moves towards zero. And this could happen if the amount of positively charged ions inside the cell will increase. So inflow into the cell of sodium and calcium, or if more potassium ions will remain inside the cell, can cause depolarization. Hyperpolarization is the state when membrane potential becomes more negative. And hyperpolarization most frequently is caused by increase in outflow of potassium ions from the cell.